Hello everyone. So based on the previous videos, we create one PLC project based on the TIA portal, and we use this i7-1200 as the PLC controller, and we use the DLPN1 Profinet device to communicate with two IX amplifier. One is a IX1000, one is a IX1050. Show you as a picture. The DLPN device is on the right side of this main unit. And in the previous video, the PLC already set up the communication with the DLPN1 device, and we already tested the communication. Currently, the i7-12 controller and this IX sensor laser devices, they already communicated. In the previous video, we also introduced, based on this communication list, this manual that is a DLPN1 user manual. Those map lists are very important. So let's quickly review those I/O address. So in the PLC address, we assigned the 6 slots here. The 0 slot, it starts from the 630, and the output, it also starts from the 630. So for each slot, it takes 7 bytes. For the output, each slot, it takes 1 byte. For the first byte, that is a DLPN1, this slot start from the 630, that provide 1 error status. Others are reserved for system. The slot 1 related to this X_1, that's this address, and slot 2 that start from this 653, slot 3 that start from the 660. So the slot 1, 2, 3, the first byte, so these 3 bytes, they are feedback from the main unit. And the slot 4, that is X_4, that start from the 667. So slot 5, that start from the 674. And slot 6, that start from the 681. So from slot 4, 5, 6, the first byte of each slot, those signals come from the expansion unit. And talking about this output, the first slot, that is a DLPN1 slot, it starts from 630. So they all reserved for system. So from the slot 1, that is a slot 1 X_1, that address, that is a 631. For the PLC, that's the Q631. These are the main unit trigger signal, reset signal, or zero offset request. So the second slot, that is the X_2, 632, that is the main unit program change command. So slot 3 reserved for system, and from slot 4, that is the expansion unit trigger signal, reset request, and zero offset. So this slot, that is X_4, the output address, that is 634. Slot 5, that is the expansion unit program change. So this address, that is X_5, output, that is 635. So those are very important signals. So based on this PLC address, input, output in this list, I created one tag list. So in the PLC tag list, I create a new tag table. And in this table, based on we discussed, so I created this list here. So this error global, that is the slot 0.7, this is the error status. And next one, job change from the main unit, that is this bit. And next one, trigger response, this is this. So, and follow this list, I create this list. And maybe you will find there's a one ID 649. That's because this is a measurement value 1. That is this portion. So the measurement value 1, it takes 4 bytes here, that is the integer value. So I put a dword input ID 649. So this address can read the measurement value from the measurement value 1. And this external output number 1 from the main unit, that is from this slot 2, the first bit. So that is this, the laser sensor input external output number 1 from main unit, that is 653.0. So if we quickly review what the difference between the external value and the measurement value. So if we quickly review, so this software, that is a IX Navigator. So we set up the two tools, 2001, 2002, and at the end of the configuration, we will go to the output. The output, the system will give you 10 slots. You can assign different tools result to this output assignment. So the output 1, that is the total status, and output 2, the busy of this unit. So this output 1, that talk about this external output 1 main unit, and the second external output 2 main unit, that is this busy signal. So in this list, that is this area, external output. And this 4-byte value, measurement value 1, in this list, we go back to this area. So this measurement value 1, where this value comes from, where is this value configured. So if we go to the sensor portion, we go to the advanced sensor setting, go to the device, go to setting. So this is a simulation wheel. So it doesn't allow me to set, but if you are using an actual sensor and shift the sensor to offline or programming mode, so you can assign this. This number 1, this is the logic channel of this measurement value 1, value 2, value 3, 4, 5, 6. So you can assign this value comes from main or come from the expansion unit, the tool value from here. So you can assign this slot. Keep in mind, we are using the main and the expansion mode because we are using the main 1000 as a main unit, and its left side, that is the expansion unit, that is a 1050 module. All right, so based on this previous information, it's a huge information. So personally, highly recommend before you go on site, you better print this Profinet communication user manual. This manual just 50 pages. At least you'd better print this map list. In the PLC side, based on the list, let's quickly review. In my case, I have a 2 laser sensor. That is the 1 unit. So each of the unit connect 1 laser sensor, and each of the sensor is measure the delta height. 201 measure the difference height of between this area. The 202 measure the different height between these 2 spots. The IX Navigator is very easy to use, and using this laser sensor can be quickly set up the system. It won't create a trouble for you. So that's why in this video, we mainly focus on the communication. So based on this case, I create this list. So I will scroll down slowly so that you can review the tag list I create. All the input value, I use the laser sensor input I here. So if the signal comes from the main unit, I will use this area underscore main unit. That means this signal represent the results come from the main unit. And if the signal comes from the expansion unit, so like this, that is an external output come from the expansion unit. I create an underscore expansion unit. So some important signal, for example, that is a job change response, trigger response, or value update complete signal. terms of the output, so very important signal, for example, the trigger signal, that is a Q signal, trigger for the main unit, trigger for the expansion unit, or reset to the main unit, reset to the expansion unit, or use the program change output or program bit. Basically, those bits can represent different program. Those are the tag list about the communication exchange tags, input and output. So let's start our main meal in this video. We will create one function block, and in this function block, we will create a logic to trigger the camera and get the result or register the result from the laser sensor result. So before we create everything, firstly, I will create one group. So I will rename this group laser group X150. This group is run the role kind of like a folder. This folder do not have a relationship with a job code. It's just like a folder organize the different function block, organization block, or function, or DB. It's a good tool to organize your function block, OB, FB, or FC. So we create a laser group X150, and under here, I will create a new block. I will create a function block. Click the function block. So I will name this function block. Manually set this number to 1002. And I will rename this function block called function FB underscore laser X. To add more network here, I will firstly add more network. We can right click, select the insert network, or press the Control plus R to create a more network here. All right. So firstly, let's create a core trigger logic here. So I will firstly write the trigger logic here. To trigger amplifier, so we need those couple logic. Firstly, we need a camera in run mode. And if the camera in run mode and the current mode, that is the auto mode, and the auto condition. So this is the auto condition. For example, if the cylinder at the position, or if the light curtain has been cleared, something like that. So this is the logic come from the outside. And at that time, if the camera is not in busy mode, and then we give a trigger command. But sometimes maybe the auto trigger condition is just a one rising edge. So to hold this trigger command, I will prefer to latch in this trigger command here. I will latch in this trigger command. So this is a very basic structure. I will create an interface here. So our camera in run mode, that is a signal come from the outside. This come from the feedback of the camera. And auto mode is also come from the outside. For example, this auto mode could be from a switch or could be from your HMI. That is a one toggle bit from manual or auto. And this trigger auto condition, that is one bit. So I will show why this. static. I will create this as a static internal tag. And this camera busy, this busy also come from the camera directly, come from here. And this trigger command, there's still some couple logic be after. So I will firstly define this trigger command that is one static tag. Okay. So go one step before. Let's think about this trigger auto condition. So to make sure this auto condition can be latched in, to make sure our trigger command be turned on, personally, I will make this logic. I will firstly rename this. For example, we rename this tag as a trigger auto condition. That is the trigger. That is the internal. So once I rename this, they all automatic changed. And here we need one auto condition that maybe some couple logic come from the function block outside, and this signal come from that auto condition from the outside. So this could be a one input that named the trigger auto condition from outside. So this is the input of the function block. I will prefer to use one rising edge. To use one rising edge. So in the function block, to assign one rising edge tag here, I will go to here to call. So this could be a trigger auto condition P trigger. And we assign this tag here. So once the outside condition meet here, so with this rising edge, we will latch in this, whatever the outside auto condition change or not, we latched in, allow this system can be triggered. Other than this auto condition, we better create a manual condition, because usually in the HMI, maybe we need a manual trigger to test the system, or by some special case, if the camera got something wrong, or reject rate got higher than before, maybe the maintenance staff will come here to shift the system into manual mode, manually trigger the camera, right? So we need to create a parallel logic. So that is a manual mode. And this is the trigger from manual control, right? So the manual mode, that is the one input, okay? So we reorganize this. So we move the camera busy up. So add this manual mode under the auto mode. So the trigger manual also come from the outside. Okay, so this is the trigger logic here. So in auto mode, this trigger command can be latched in by itself until the system got busy, so this trigger will be jobbed. So next logic, once we get a trigger, that moment, so because from the previous logic, we set this internal auto condition. But once we got the trigger and we control this command outside to the outside, so we can reset this until the next time is auto condition got a rising edge. So from here, so we also use a rising edge here. For example, we call this rising edge, go to the static here. So we call the trigger 1 command p trigger. Assign one tag to this p trigger, and from here we reset this auto condition. Okay, maybe someone will ask why we put the busy logic here. So let's talk about one thing. What the timing chart of this laser sensor. So to figure out the timing chart, we need to go to one menu. So this menu, that is a image laser sensor user menu. If I go to the controlling timing of the judgment with the triggers, scan mode, from this bookmarks, keep in mind in this image laser sensor, it has a two mode. One is a scan mode, one is a line mode. Let me quickly explain a little bit about this two modes. We go to the chapter 3, page 3. So the line mode means the part is keep moving. So the laser sensor mounted as this. So it keeps scanning part when the part is moving. Scan mode means the part is a static mode. The part is present here and the camera take the picture. In my case, the part is a fixed position there. After the part is present, and the logic will trigger the laser sensor. So what I'm using, that is a scan mode. So if we go to the scan mode to trigger timing chart, so we can see the external trigger signal. Once it got the trigger signal, this width of this trigger signal must be greater than 100 milliseconds. And after the camera got the trigger, so it will shift to a busy mode. So this busy will turn on till the processing done, till the tool processed the results. And once the busy signal dropped to 0, that means at that moment the judgment process or the judgment result is ready to be registered. So we can see this is a judgment process, and once this busy from on to off, at that moment the result from the trigger 1 is turned on. So we can think about the two parts. Firstly, once the system gives the trigger, when this signal can be dropped, that means if the busy already turned on, that means the camera already got the trigger signal from PLC. At that moment, this trigger can be dropped. So if we switch back to our logic here, so this trigger signal will go to outside to trigger the laser sensor. So that means once we got a busy signal, so this signal can be dropped. And if the sensor haven't got a signal, that means this busy was off because the laser sensor basically is waiting for the trigger. So this signal will be latched in to turn on till the sensor got the trigger signal and give the feedback to the PLC, say, I'm busy. So at that moment, this trigger signal can be dropped. So this is the trigger portion. And let's think about how we can register the result. From this network, we can name this register results. When we talk about the results register, so we need to think about which moment is the best moment to register the result. If we go back to the menu, from here we got the trigger 1, and the laser sensor gets this trigger, become busy. And when the judgment process finished, so this busy turned off. At this moment, so this result will come up. So from this picture, we can see when the busy from 1 to 0 drop age. So from this moment, we can register the result because it shows here. So minimum 200 milliseconds. That means the result already be ready for the busy from 1 to 0. So that means we can use this busy dropping age to register the result. All right. So from here, that means to register a result, we'd better use the rising age. So to program a register result logic, we can do this way. Firstly, we also need this camera in run mode. And next one, in the function block, we can call this camera result ready. And this result ready can come from the function block outside. We could use the not busy as a result ready signal. So this result ready signal comes from the outside. So we can assign here. So camera result ready. And to guarantee this result ready turn on, at that moment the actual result can be ready. So we could put a timer here. For example, put a TON timer. So in this function block, to assign one timer tag, so we should use multiple instant camera TON. And we can set a time delay. That time delays allow this result can be guaranteed ready. So for example, we can set 100 milliseconds. So that means, so if the system is ready to be registered, we still wait 100 milliseconds. And after that, we register the result. And where is this timer tag? So after we assign the cam result ready TON, so this timer go to the static here. So the date type, that is a TON time. And from here, we can use this once the timer get it .q result. From this moment, we can assign one rising age, and we register the result. So from here, we can call this result ready rising age. And this rising age tag, that is an internal tag. And that is a bool. Okay, so we also need to assign one tag here. So we can call this rising age P trigger. Assign this tag to this P trigger. So that means if the result get ready, so we still wait 100 milliseconds to guarantee the result is actually ready. And after that, we give the one trigger. So at that moment, the system must be totally ready to register the correct result, whatever is pass or fail. Once we got the rising age, from the next line, we can register the result. For example, once we got this rising edge here, it's just run one cycle rising edge. So we can register the result, for example. So this could be come from the camera result, judgment result, and we can latch in or set reset to hold this result. So for example, from the input, we can register the camera, for example, camera judge, okay. Camera judge fail, NG. So this is from the actual result from the camera, and this comes from the camera result fail. And from here we can set. So at this rising edge moment, if the actual judgment result come from the camera got okay, so we will latch in this result. Inspection pass. Next one, camera inspection fail. So these two results that can be the output here. Maybe someone will ask me why we need to put this logic. Why not just put this judgment OK to outside? That's because maybe for this sensor, actually we do not need to do this logic. That's because this sensor can hold this result until next time you trigger it. But however, because we are doing a function block, I try to use this function block can be used for long term for more sensors. So maybe some sensors that result cannot be latched in, cannot be held. Maybe once you trigger that, that result pass or fail result maybe just turn on for a short moment. To make the logic uniform for other sensors, so I prefer to do this way. Whatever this result can be latched in or just a one short moment. So we use the latch in result, latch in the pass, or latch in the fail result. And we can call this network that is a register results. And the last network, so this is the register result for rising edge. See, we got a ready signal and got a trigger, and then we latch in this result. So we have a set logic here. So with this, we also need a reset. So which moment we need to reset it? So we can reset this 2-bit here. We can reset this 2-bit here. So every time we trigger this laser sensor, that moment we reset pass or fail result, waiting for the new results coming back. So firstly, we reset this, and we are waiting for this reset ready. And once the reset ready, we, based on the judgment OK or judgment NG fail, we re-register the pass or fail. This is the basic idea of this logic. And also, you might use the first run to have a global reset signal. For example, let's put the first line as a reset. And this network, the role is reset all. So from here, we reset this. Firstly, we reset this auto condition internally. In case it only get a set, it haven't got a reset by in case, for in case condition. And also we can reset those signals. So this reset signal can come from the auto sequence. For example, in the automation program, we will program a sequence logic. For example, in your process, maybe you have a 20 sequence, step 1, step 2, step 3, step 4, right? Maybe the step 10, at the step 10, it will go to trigger the camera. But maybe at a step 8 or step 1, at step 1, you could trigger this reset signal. If the system starts from the new cycle, at the beginning of the cycle, so you can reset all this result, make the system ready to be triggered. And once the step gets a step 10, the auto condition meet. So at that moment, it's got a trigger, and we latch in this auto condition. And at that moment, if the system in auto mode and the camera is not in busy, it will trigger the camera. And once we trigger the camera, the system is waiting for this camera result ready, turned on. Once it's turned on, we still wait 100 milliseconds to register this result. So once we get this rising edge result, we register this result. So this is the core signal. So other than this core signal, we could grab this rising edge to go outside to do other register result. For example, we can come here, output, rising edge, result, output. Okay, and so that is the output. Okay, and this is the output. So this is the core of the trigger logic. And from here, we could write this. This is the trigger command reset. Write some comments. So I will show the beauty of these comments because from this KI portal, we can use this, close all the network or expand all the network. So once we close with this comments, we can quickly go to the network we are going to find. Especially when we found some problem, we need to go inside the function block, try to troubleshoot the logic problem. So for example, if the rising edge got something problem, so we can quickly go to the register result network and expand that so we can quickly find out the problem. So I highly recommend for some key network. So ideally, every network we'd better write some comments here. So for example, network 2, if there's no comments here, we don't know what the inside in this network, right? Until we open it, we know that. So if you already write something here, so we can quickly navigate which network we are going to find. All right, so once we finish this function block, usually we need to create one function to call this function block. So let's close this function block. From here, we save the project. In next video, we will set up one function that named FC910 laser sensor inspection function and use this function to call this function block FB1002. And also I will show how we can use this tags from the input and the signal go to the output, and how use this signal connect to this function block. See you in next video.
Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe. See you in next video.